Hello students, welcome to Srinath. In this video, we are going to learn the first chapter in the CBSE Class 8 Maths. My name is Karthik Nunne. We are creating all subjects from CBSE Class 6 to Class 8. So please subscribe our channel, also follow on Instagram and join our Telegram channel. Please feel free to comment below or comment on our videos if you have any doubts. Okay, now we are going to learn this chapter. Okay, what is the name of the chapter? That is rational numbers. Okay, it is the first chapter in the 8th class maths. Okay, rational numbers. Okay, how many topics in this chapter? We are having 4 topics. What it is? We are having 4 topics in this chapter. Okay, we are going to learn all these 4 chapters, all these 4 concepts in this chapter right now. Okay, in the beginning we are going to have an overview of all the 4 topics. After that we will discuss each topic in detail. Now we will enter into the overview. Okay, the first topic in this video is the introduction. Basically what we are going to learn in the introduction means we are going to recall what we have learned in the 6th class and 7th class number system. Basically about the whole numbers and the integers. We are going to recall what are the, how we add integers, how we subtract integers, how we multiply integers, or same regarding to whole numbers, and what are the properties of those numbers and the additive universal, like that. All those we are going to recall. It is in the first topic. Just now the second topic is properties of rational numbers. So then what are the rational numbers, how to add rational numbers, we have studied about it. Now what we are going to do, study the properties of the rational numbers. Basically what are the properties? Basically closure, the distributive, like that. We have some properties. We are going to discuss all the properties under addition, subtraction, multiplication and division, like that, operations. Okay, that is about the second topic. Okay, this is all about the second topic. Okay, after that, after completing the second topic, after discussing the properties of the rational numbers, we will come into the third topic, that is representing the rational numbers in number line. Okay, we are going to represent the rational numbers on number line. Basically we have learned about representing natural numbers on number line, we have learned about representing whole numbers on number line, and we have learned about representing integers on number line. Now in this chapter we are going to learn how to represent rational numbers in the number line. Okay, that is about the third topic we are going to learn. After that we are going to learn the fourth topic, what it is, rational numbers between rational numbers. We know what are the integers between any two integers and what are the whole numbers between any two whole numbers. In this way we are going to learn what are the rational numbers between any two rational numbers. Is it the same? Is it the case of rational numbers is same as the case of whole numbers, or is there any difference? We are going to find out that reason, and we are going to find out that logic. Okay, this is the chapter. So that's it. So at this point our chapter will be completed. Okay, now we are going to have an complete discussion on our chapter where we are having basically 4 topics and we are going to learn all 4 topics. Okay, in this chapter we are not solving any exercise problems. If you want exercise problems to be solved, please comment below. If we get sufficient number of comments, then we will upload separate videos on the exercises, so that all the problems in the exercises will be solved on that videos. Okay, if you really want the exercises from you, then please feel free to comment below. Okay, now we are going to start our session. Okay, the first topic is introduction. Generally what is there in the introduction? Generally, if you observe this equation, x plus 2 equal to 13, if you want to solve this, then what is the value of x here? It is nothing but x equal to 13 minus 2, that is equal to 11. If you similarly observe this equation, what is the value of x here? That is equal to x equal to 5 minus 5, that is equal to 0. Here 11, which is a natural number. Okay, here 0, which is a whole number. Next, x plus 8 equal to, what it is? X plus 8 equal to 15. That implies x equal to 5 minus 18. Then what is the answer here? That is minus 13, which is an integer. Then there is another equation, that is 2x equal to 3. From this equation we are going to solve the value of x. Then it will becomes x equal to 3 by 2. So then what this number is? Then what is this number is. We until now we didn't find or observe any number like this. We have observed numbers like this, natural numbers, they are starting from 1 and so on goes to infinity, and we have observed whole numbers, they are starting from 0 and goes on infinity, and we have observed integers, they are starting from minus infinity and goes to 0 and 0 to positive infinity. Now we have also observed the negative numbers, but we didn't observe any numbers in the form of like this 3/2. So what are these numbers? We called it as, so we call these numbers as rational numbers. What are those numbers? Rational numbers. Okay, this is the heading of our topic. In this chapter we're going to learn about rational numbers. So you may think, what are rational numbers, how they are coming, how they will looks like, means they are in the form of the rational numbers will be in the form of p by q. They are in the form of p by q, and p and q are the integers. What are those? They are integers. They are integers. Okay, basically in this example also the x value is equal to -7/5. So these are called as rational numbers. Okay, they are in the form of p by q form. Okay, we have already seen basic operations on rational numbers. We now try to explore some properties of operations on the different types of numbers seen so far. Okay, basically in our previous classes we have learned, we have an encounter with the rational numbers, and they are in the form of p by q. Basically regarding rational numbers, what are the few things we have to remember in our mind, or what are the few things we have to remember, means one is rational numbers are represented by the letter q, and they are in the form of p by q, like example 1/2, 3/4, like that. Okay, and what are p and q? Here the main condition is p and q are integers. What are these? Integers. So rational numbers are nothing but the integers, but one difference is they're in the form of p by q, which means one integer is on a numerator and the another integer is on the denominator. We call this as numerator and we call this as denominator. I think you have learned it in your primary classes or in your previous classes. This is called as numerator. So one thing, so you have to keep mind in one or two things, that is rational numbers is represented by q and they are in the form of p by q, and p and q are the integers, and another thing is q not equals to 0. These are the three conditions must follow for a rational number. And how to add rational numbers, how to subtract rational numbers, how to multiply rational numbers, how to divide rational numbers, we have learned in the previous classes. So until now the introduction about rational numbers is completed, which means our first topic is completed. Then how many topics we are remaining? We are having 3 topics remaining. Without wasting time, we'll complete all those chapters, all those topics also. We have entered into the second topic, that is properties of rational numbers. Then regarding properties, what are the properties we have? Basically the properties like closure property and associative property. These are the properties we are commonly having, and distributive property and commutative property and some other properties also. So all these comes under properties. Okay, all these comes under properties. Now what are operations? Operations means not surgical strikes or surgical operations or any cesarean operations. What are the operations here? Means we are studying maths, so our mathematical operations like addition, okay, addition, subtraction, multiplication, division. Okay, all these are the operations. So these are the properties and these are the operations. So properties will act on all operations. That is, closure property is same, closure property is 1, but there are closure property will is there on addition, closure property will be acting on subtraction, closure property will acting on multiplication, closure property will acting on division. And at this in the same way associative also, it also associative under addition, associative under subtraction, associative under multiplication, like that. So that every property may be operated under different operations. The operations are basically addition, subtraction, multiplication, division. So closure property is same, but in every situation if it is under addition, then we have to add the numbers. If it is under subtraction, we have to subtract the numbers. If it is under multiplication, we have to multiply the numbers. If it is under division, we have to divide the numbers. Then I am repeating that numbers, basically numbers. So closure property is same always, but it acts eventually on addition, it acts on subtraction, it acts on multiplication, it acts on division also. And this same closure property is acting between numbers. Which numbers? Natural numbers, whole numbers, integers, and here also rational numbers. So in the case of all these numbers also there is closure property, and in the case of every number there is suppose example, in the case of natural numbers there is closure property. In the case of natural numbers there is closure property, and that closure property is under addition, and that closure property is in subtraction, and that closure property in multiplication, and the closure property in division. So again for whole numbers also there is closure property, and this is also for four operations. Like that we are having we are using different types of numbers, we are doing using different type of operations, but the properties is the same. Properties same. So this is about all properties, numbers and operations. Basically now by now we are discussing about the closure property under whole numbers. Under which numbers we are using here? Whole numbers. Okay, and what are the operations we are using here? We are using addition, subtraction, multiplication and division. What happens? What basically closure property tells? Closure property tells that suppose if you take the operation of addition, and if you take the numbers as whole numbers, then if you take two whole numbers like that a comma b, these two are the whole numbers, which means they belongs to whole numbers. Then if you add them, we are taking the operation as addition. Then if you add them a plus b, then it will give some result. This result must be whole number. Then result must be whole number. Then only closure property satisfied under addition for whole numbers, this property again for if you change the operation and for the same whole numbers, what happens? Then again a and b are whole numbers, and again you have to do operation. What is the operation? Previously you have add them, addition. Now we will consider subtraction. Then a minus b, what happens? A minus b. Then also we will get some result. So this result must also be belongs to whole numbers. Then only we said closure property is satisfied. In this way you have to do closure for addition, subtraction, all those. This is the for whole numbers. This will be repeated for integers also. And finally our main concentration is on the rational numbers. For whole numbers, the closure property addition. What happens? If you add two whole numbers, you will get again whole number. So what is the remark? What is the means? Whole numbers are closed, satisfies the closure property under addition. If the operation is subtraction, if you take two whole numbers and subtract, you will get a result which is not a whole number, So whole numbers are not closed under subtraction. Under subtraction operation, it is not closed, it is not satisfies the closure property. If you take multiplication, if you take two whole numbers and you multiply it, what happens? You will get another whole number. So what happened? Whole numbers are also closed under multiplication. So in the case of multiplication also closure property is satisfied. Now we are changing our operation to division. If you take two whole numbers and you make division, you are not getting any whole number. So what happens? So closure property is not satisfied here. In this case, this is regarding about whole numbers. Same closure property. Now same closure property for integers. What happens? Addition. So what happens in integers? In addition, what happens? If you take two integers and add them, what happened? They are closed under addition, which means you are getting another integer. Okay, in the same way, if you subtract two integers, you are getting another integer. So integers are closed under subtraction also. In subtraction also integers are closed, which means closure property is satisfied. In the same way, you are taking multiplication, taking two integers and multiplying, you will get another integer. So in the case of multiplication also it is closed, means satisfied. In the same way, you are taking two integers under division but you are not getting integers, so it is not closed. Okay, in this way you have completed for whole numbers and integers. Then what about rational numbers? Rational numbers are in the form of p by q. Now we are going to do it for addition property. What happened? Suppose take example of here they tag example this 3 by 8 and minus 5 by 7. When they add, you will get the result of minus 19 by 56, which is a rational number. So what happened here? A and B, that is 3 by 8 and 5 by 7 are rational numbers, belongs to Q. Q means rational numbers. The symbols represents belongs to, which means they belongs to Q, means rational numbers. Then finally what happened? A plus B, which is equal to we get some result. That result is also belongs to rational numbers. So what happened finally? Closure property satisfied. What happens? Satisfied under addition for rational numbers. Rational numbers are represented by Q. Okay, now the same closure property for subtraction. Here it is for subtraction. What happens here? Taken two rational numbers, minus 5 by 7 and 2 by 3. What happened after subtracting? They are getting minus 29 by 21, which is also a rational number. So what we have concluded? That it is closure satisfied under subtraction also. That is for any two rational numbers A and B. A minus B here, A minus B is also a rational number. We are getting the rational number under subtraction also. So it is satisfied. It is a closure property satisfied under subtraction also. Now we move into the product, which means multiplication. What happened? Take two rational numbers and you multiplied it, then you will get another rational number. So what happened finally? Rational numbers are satisfied or closed under multiplication. So what happened? For any two rational numbers A and B, A cross B also rational number. So closure is satisfied under multiplication also. Now we have coming to the division. Take two rational numbers and divide those rational numbers. What you are getting? In some cases you are getting minus 25 by 6 as a rational number, which is a rational number. But if you divide a divided by 0, then what happened? The result is infinite, not defined. So here defined. Okay, wait a second guys, not defined. So which is not a rational number, not Q means not rational numbers. So not defined, so not satisfied, not closure not satisfied. So finally what happened? Rational numbers are closed under addition, subtraction, multiplication, but not under division. In under division they are not closed, which means they are not satisfied the closure property. So that's it for closure property. Now we move to the commutative property. What commutative property tells that? If you take this follows this rule: A plus B equal to B plus A. What does it mean? Suppose if you take A equal to 1 and B equal to 2, what happens for LHS? That implies 1 plus 2. What is the value? That is 3. RHS, what is the value? 2 plus 1, that is also equal to 3. These two, LHS is equal to RHS, which means A plus B equal to B plus A. If what is the commutative property? Means if you do any operation, if you want to consider as commutative property under addition, and take these are as the whole numbers. Suppose whole numbers. In the beginning I have told you that every property is same, but it acts on different operations and different numbers. Suppose if you want, in this case you have taken addition operation and whole numbers, and And in this case, what happened if a plus b equal to b plus a, in the a and b are the whole numbers, and the operation between them is addition. If these whole numbers is added and their places interchanged, then also added, then if you get the same result, then we say that commutative is satisfied for whole numbers, for which numbers? For whole numbers under which operation? Under addition operation. This is the actual scenario. So what we have to do? We have to do it for first whole numbers, and in whole numbers we have to do for different operations like addition, subtraction, multiplication, division. And next we have to move to integers, and for addition, subtraction, multiplication. Basically for whole numbers and integers we have done it in our previous classes. So just we are recalling it. But rational numbers we are doing now itself in this class. Okay. When you take whole numbers and you take addition operation, what happens when you take two whole numbers and you add them, and after interchanging their position also you are adding them, then what happened? The result is same. So addition is commutative. It is commutative. In the case of subtraction, if you interchange the digits, it is not giving the same value, so it is not commutative. In the case of multiplication, if you are changing the digits, if you are interchanging the numbers, we are getting the same value, so it is commutative. In the case of division, if you are interchanging, it is not giving the same value, that is not commutative. Now coming to the integers also, what is the difference here? The property is same, but you are taking integers and doing all the four operations. In the case of addition operation, if you are interchanging also, the integers also giving the same value, so it is commutative. But in the case of subtraction, if you are interchanging the numbers, it is not giving the same value, that's why it is not commutative. But in the case of multiplication, if you are interchanging the integers, it is giving the same value, so it is commutative. But in the case of division, if you interchanging the numbers, it is not giving the same value, so that's why it is not commutative under division. Okay, this is all about whole numbers and integers. But now our concentration and our main theme is on rational numbers. What happens when rational numbers are added, and what happens when the digits are or the numbers are interchanged? Suppose take two numbers, that is -2/3 and +5/7. When you add these two numbers, the result is 1/21. And again, now what you have done, you have interchanged these two numbers, that is 5/7 and -2/3, and again added. This is under addition, so added. Then what is the result? In this case also we are getting 1/21. Like that you have to do remaining examples also. Finally, what you have concluded, that is for any two rational numbers a and b, a plus b equal to b plus a. So it is done. It is satisfied the commutative law. Now we are taking subtraction. In this case, if you are taking two rational numbers and are subtracting, you are getting one number. When you are interchanging these, you are getting another number. If you have doubt, please solve this, then you will get clear idea. So what happens finally in subtractions will not commutative. It is not commutative, so it is not accepting. But when you coming to the multiplication, if you taking two rational numbers and you are multiplicating, you are getting some value, and at the same time, if you interchange those numbers and doing the multiplication, you are getting the same value. So what happened? A cross b equal to b cross a. So what happened in this case? It is satisfied. Under multiplication, commutative law is satisfied. Now coming to division, what happened in coming to division? If you take two rational numbers and you divide, you will get some value, and if you are interchanging those numbers, you are not getting the same value, so it is not commutative. Finally, commutative law for rational numbers, integers, whole numbers, natural numbers. In the case of rational numbers, the commutative law holds for addition only. Okay, and it is holding for multiplication also, in some cases multiplication also, but it is not holding for subtraction and division. It is holding for multiplication also. Here it is multiplication. You will find the multiplication is commutative for rational numbers. In general, a cross b equal to b cross a. Here there is a printing mistake. For integers there is no. Subtraction is no. Like that for remaining numbers. Now we have completed the second property also. That is the next property is associative property. What is the associative property? Means basically if you are having three numbers, and if you are doing any operation, for example, take addition. operation is addition, and numbers as whole numbers. A and B and C. What quantitative law, associative law tells that suppose you are taking addition, and if you do this answer, in this case you are taking these two numbers at a time, and the next case what you are doing, in the next case what you are doing, in the next case you are taking these two numbers at a time, which means A plus B bracket plus C. In this case you are solving first this, and after this solving this. In this case you are solving first this, after this solving this. So finally what associative law tells that the answer in these two cases is equal. If equal, then it is associative under addition for whole numbers. Then it is associative under addition for whole numbers, which means A plus B plus C is equal to A plus B plus C. If this is satisfied, then we say that it is satisfied under addition for whole numbers. For example, if you take A, B, C, A equal to 1, B equal to 2, C equal to 3, what happens? A equal to 1 plus B equal to 2 plus C equal to 3, like that. Then this is LH set, this is the RH set, 1 plus 2 plus 3. So what happens? What I have previously told you, you have to first solve the numbers which are in the bracket. So 1 plus 2 plus 3 gives rise 5, that is equal to, here we have to first solve the numbers in the bracket. So here 1 plus 2 gives rise to 3 plus 3. So what happened? Now we have to solve remaining. 5 plus 1 gives rise to 6, 3 plus 3 gives rise to 6. LHS equal to RHS. So what happened? A plus B plus C is equal to A plus B plus C. So finally what we can told that whole numbers are associative under addition. Whole numbers are associative under addition. This is the property. We are changing this same property for different operations, like here we will multiply, we will subtract, and we are taking different numbers like whole numbers, integers, rational numbers, like that. So coming to this property here for whole numbers, for addition what happened? Addition is associative, and if you take subtraction it is not associative. If you take multiplication it is associative. If you take division it is not associative. If you take integers, what happened? If you do addition, it is associative, which means integers gives the same value, LH is equal to RHS. If you take subtraction it is not satisfying, but you take multiplication it is satisfying. What happens in this case? What is the formula? Means A cross B cross C. Multiplication is equal to A cross B cross C. In the case of multiplication, just we are changing the operations. If you have addition, plus, if you have multiplication, into, if you have subtraction, minus, if you have division, like this only, it is satisfying. But in the case of division it is not satisfying. Integers are not satisfying. Then our main important and main aim target is rational numbers. Now we are going into the rational numbers, and we are finding for associative property under different operations. First our concentration is on addition. Basically take 3 rational numbers, and like that, minus 2 by 3, 3 by 4, and minus 5 by 6. In the what you have to do, first you have to calculate these two. We have to solve these two. In the same case, next you have what you are doing in another case, that is RHS. You are taking these two, and you are calculating these two, and after that adding these two. In these two cases, what happened? After calculating you are get the same answer. So what happened? A plus B plus C is equal to A plus B plus C. So finally it is satisfied. So what we have told that rational numbers are accepting, or rational numbers are supporting which property? Associative property. Rational numbers are supporting or accepting associative property under addition. Here it is. We find that addition is associative. Addition is associative for rational numbers. Addition is associative for rational numbers. This is the formula. Now subtraction. In the case of subtraction it is not accepting. In the case of multiplication it is accepting. That multiplication is associative for rational numbers. The formula is A cross B cross C equal to A cross B A cross C. Now coming to the division, what happened in this case also? It is not accepting. So finally, after concluding that, what happens in the case of rational numbers? What happened in the case of addition? It is accepted. In the case of multiplication it is accepted. So that our associative property is also completed. Now another property is role of 0. What is the role of 0? Okay, what happens if you add 0 to any number? Like if you take whole number, what happens? It will give the same number. So 0 is called the additive identity. Okay, additive identity. In the same way, if you add 0 to any rational number, what you will get? What you will get? You will also get same. You will get the same number. So in this case also if you add any number like that, if you add 3 to 0, we will get 3. 3 is a whole number. If you add minus 3 to 0, you will get minus 3. Minus 3 is a integer. Similarly, if you add any integer like minus 2 by 7 to 0, what is the answer? You will get minus 2 by 7. Here it is the q, rational number. So what we can finally tell that 0 is additive identity. Additive. In the case of additive, no, so additive identity of rational numbers. Additive identity of rational numbers. What is the additive identity of rational numbers? If anybody asks you that question, what your answer is? That is 0 0 0 rational numbers. Okay, which is the additive identity. What is meant by additive identity means if you add anything to the additive identity number, it will give the anything, which means if you add a to the additive identity, which is 0, which is the additive identity, then you will get the a also. If you add any integer, or if you add any whole number, or if it is regarding about rational numbers, if you add 0 additive identity to any rational number, then it will give the rational number. For that reason, we call it as additive identity. Okay, this is about role of 0. Now what is about role of 1? What is the role of 1? If you multiply any number with 1, what you are getting? Suppose if you are multiplying any number with whole number, what you are getting? You are getting that number. So what we called it, it is called as the multiplicative identity for whole numbers. In the similar way, if you multiply any rational number with 1, you are getting that number only. So what we called 1 is the multiplicative identity for rational number. So 1 number 1, which is called multiplicative identity. Multiplicative identity for rational numbers. So what is meant by additive identity? If you add any number to the additive identity, then you will get that number. What is meant by multiplicative identity? If you multiply any number with the multiplicative identity, which is 1, you will get that number itself. So that is called multiplicative identity. Here a suppose is a rational number. If you multiply it with 1 is the multiplicative identity, then you will get a. In the same way, if you multiply 1 with multiply 1, which is a multiplicative identity with a rational number, you will getting that rational number only. So this is the case of additive identity. This is the case of multiplicative identity. What is the additive identity? Which is 0. What is the multiplicative identity? Which is the 1. In the case of rational numbers, this is the main thing. In the case of rational numbers. Okay, now our next subtopic, another subtopic is negative of a number. What is the negative of any number? Suppose if there is 2, what is the negative of this number? That is minus 2. Then what is the negative of this number? If you want negative of this number, what you have to do? You have to put negative symbol. So negative of negative 1 minus 2. What is the answer? The answer is minus of minus, which gives the plus. So answer is 2. So minus 2 is the negative of 2, and 2 is the negative of minus 2. Can you understand? Minus 2 is the negative of 2. 2 is the negative of minus 2. So in case of integers, we will observe this is 0, and this is 2, and this is minus 2. If anybody asks what is the negative of 2, then you will say that is minus 2. Then what is the negative of minus 2? Which is nothing but 2. What is the negative of 2? That is minus 2. And what is the negative of minus 2? That is 2. We will get negative numbers in the integers. Okay, or now in the same way, what happens in which case you will get negative numbers, or how negative numbers is determined? If you add both these numbers, suppose if you add any number to its negative or negative number, negative integer or negative number, what happens? If you add suppose here 2 is the number, if you add this 2 to its negative number, that is minus 2, what happens? The resultant is 0. So which is called as additive inverse. So minus 2 is called as additive inverse. Additive inverse means what? Additive inverse is nothing but if you add any number to its additive inverse, the resultant is 0. If you add any number to its additive inverse, then its result is 0. Okay. For example, in the case of whole numbers or in the case of integers, 2, it is a number. If you add 2, its additive inverse minus 2, then what is the answer? That is 0. In the same way, minus 2, this is the number. If you add negative of this number to this, what happened? Negative of minus 2 is 2. Then what happened? The result is 0. So minus 2 is called the additive inverse. Minus 2 is called the additive inverse of 2. Here 2 is called the additive inverse of minus 2. So when you add a number with its additive number, its resultant will be 0. This is in the case of integers. This is true for this. We are going to prove it for rational numbers. If you take any rational number, suppose 2 by 3, which is a rational number, then what is the negative of this rational number? That is minus 2 by 3. Then if you add this negative number to this real number, what happened? The resultant is 0. Then minus 2 by 3 is called additive inverse of 2 by 3. In general, what we can do, that minus a is called additive inverse of a. And for all, it is a symbol of for all. If you can't understand it, I will leave it. For all a belongs to q, which means rational number, which means a, it is an rational number, which means it is like in the form of 2 by 3, like 2 by 3 or anything. Then if you add a to its additive inverse, minus a is it additive inverse, then the answer is 0. And here minus a, it is the number, it is the negative rational number. If you take its additive inverse, that is a, then the result is also 0. Then 0. Finally, what we said, minus, suppose basically we are taking a rational number, so that's we are writing as a p by q form, that is a by b. So minus a by b is the additive inverse of a by b, and a by b is the additive inverse of minus ab. This is about additive inverse. Now coming to the reciprocal. What is the reciprocal? Suppose if you take a rational number like that, 8 by 21, then what is the reciprocal of it? If you want to find out the reciprocal of it, you have to multiply it with its reciprocal. If you don't know it, in the simple way you get it is the multiplication of a number with its reciprocal gives the value of 1. What it is? The one thing you have to blindly believe is, if you multiply any number, this is any number, with its reciprocal, the resultant is 1. So then what might be this number? Can you guess this number? Here 8 by 21 is the number, and the resultant after multiplication with some number, suppose it is taken as x by y, so it is taken as x. Okay, 8 by 21, after multiplying with x, you will get 1. What is the thing means? If you take any number, if you multiply that number with a reciprocal of that reciprocal, then your answer must be 1. Then your answer should be 1. So initially we didn't know what x means, which means initially we didn't know what reciprocal means. So now we are going to find out this reciprocal. It is very easy. Why? Because means we know the RHS, which is 1. No other chance. It must be 1. So finally what is x value? That is 21 by 8. Because it has moved to this side, it is moved to downside. So finally what is the x value? That is 21 by 8. If you have any doubt, now multiply 8. Take LHS, which is 8 by 21 into x. We have find out the value of x, that is 8 by 21 into 21 by 8. Then what is the answer? 8 will one time cancel, 21 will one sum cancel, 1 into 1 is 1. So what is the RHS? RHS is 1. So finally what we have concluded, that 21 by 8 is the reciprocal of 8 by 21. So finally what we have concluded that if any number is multiplied with its reciprocal, then the answer will be 1. 1. So here, so can you say that what is the reciprocal of 0? Can you say what is the reciprocal of 0? We can't say. Is there a rational number which when multiplied by 0 gives 1? Is there any rational number which when multiplied by 0 gives 1? What I have said previously, so any number which is multiplied is reciprocal, then it's where it will give the value of 1. Suppose if there is any rational number which is multiplied by 0, suppose if you take 0 and multiply it with any rational number, we don't know, then it will give 1. No, it does not give 1. Thus 0 has no reciprocal. What one thing we are kept in mind is 0 has no reciprocal. 0 has not having any reciprocal. But if you want to find reciprocal of any number, simply multiply it with x and equate it to 1, then you will get it. Or simply if you want reciprocal of any number, just make its denominator into numerator and numerator into denominator. Suppose 8 by 21. If you want the reciprocal of this 1, what you have to do? You have to do denominator into numerator and numerator into denominator. Then what is the denominator in this here? This is 21. You have to make this into numerator. Then what is the numerator here? 8. Then it goes to denominator like this, 8. Then it is the reciprocal. This is the answer you have get now finally. So one just thing you have to keep in mind is what is the reciprocal of any number. If you want the reciprocal of any number, change denominator into numerator and numerator into denominator. Simply you will get answer. But 0 has no reciprocal. We say that a rational number c by d is called the reciprocal or multiplicative inverse. In other words, you call it as multiplicative inverse of another non-zero rational number a by b if a by b and c by d equal to 1. If this condition is satisfied only, then c by d is the reciprocal or in multiplicative inverse of a by b. Okay, if this condition, what is that condition? If you multiply any number with its reciprocal, or if you multiply any number with its multiplicative inverse, your answer must be 1. Your answer must be equals to 1. If this condition is satisfied, then only that the reciprocal is correct. Okay. Now, what is another property? Distributivity of multiplication or addition for rational numbers. Basically, what this property is, a into b plus c is equal to a cross b plus a cross c. This is only for addition and subtraction only. This is not having for all operations. A cross b minus c equal to a cross b minus a cross c. This is the distributive over multiplication of addition. Okay, or distributive over multiplication of addition under subtraction. This is valid for whole numbers like that. Now our aim is to find it for rational numbers. Thus rational numbers follows this distributive of multiplication over addition. Now what we are doing, we are taking a b c. Here what is a is the, here what you are going to take to understand this, we are taking three values, minus 3 by 4, 2 by 3 and minus 5 by 6. Okay, what we are doing initially, we are multiplying a cross b plus c, that is minus 3 by 4 cross 2 by 3 minus 5 by 6. It is the LHS. Finally, what the answer we have get after doing these experiments, you will get 1 by 8. Okay, 1 by 8 your LHS answer. Now we are doing RHS. What is the RHS? RHS is a cross b, a cross c. A cross b is a is this, b is this. So minus 3 by 4 into 2 by 3. Answer is minus 1 by 2. And a cross c is minus 3 by 4 and minus 5 by 6. Answer is 5 by 8. Then what happens if you add this and the previous one, what does it give, which means minus 3 by 4 a cross b, a cross c, that is minus 1 by 2, 5 by 8. This answer is 1 by 8. Here RHS you are getting 1 by 8. Here LHS also you are getting 1 by 8. You are taken the rational numbers. So rational numbers, what happened? Rational numbers LHS equal to RHS. Finally, rational numbers approved or rational numbers satisfied this distributive or multiplication of addition. Okay, so finally rational numbers also prove or support distributive of multiplication or addition. We have completed this property also. Finally, we have completed 2 topics, students. Now we are entered into the third topic and we are leaving with 1 topic only. So how we will represent rational numbers on number line? Suppose if you take number line and if you take natural numbers, what happens? It starts from 1 and 1, 2, 3 and is there an arrow, and this goes on increasing to the right side. And when you consider whole numbers, what happen? In this number line also it starts from 0 and the arrow is on right side and it will goes on like that. The numbers will goes on increasing. The arrow will increasing to the right side. But in the case of integers, what happening? It starts at 0 and it goes on expanding into right side and goes on expanding to the left side with 1 unit difference. Okay. Then what about rational numbers? If you take rational numbers, they are in the form of 1 by 2, like that p by q form. So if you take the rational numbers number line, then here is the 0 and here is the 1. Then this is the 1 and there is the 2. And in integers, -1, -2, like that. Then where rational numbers will be on the number line? They will be in between the integers. In between the integers. Here 1 by 2, it is a rational number. It is in between the 2 integers 0, 1. Here it is the -1 by 2. It is a rational number. It is in between the 2 integers -1 and 0. So the line extends indefinitely. It will extend indefinitely on both sides. Rational numbers, number line will extends on both sides indefinitely. But you can now see numbers between -1, 0, 0, 1, etc. only. In this case, you will see observe rational numbers between integers like that. But in this case, in all these cases, there are no numbers between integers or no numbers between these unit distance side numbers. But in this case, rational numbers, there are numbers between integers or main numbers. Okay, and one more thing, how we will represent rational numbers means, how we will label means, suppose here it is 0 and here it is 1 and here it is 2 and here it is -1. Then if you want to represent 1 by 2, how you will represent it? Basically 1 by 2. 1 by 2, how you will represent means, which means what you have to do, the 1 by 2 value is 0.5. basically its value lies between 0 and 1. So 0 less than 1 by 2 length 1. So what we can observe from this means 1 by 2 must lie between 0 and 1. So in number line 0 is here and 1 is here. So it is at the distance of 1 by 2, which means it is at the center 1 by 2. Center 1 by 2. So if you observe, we can write 2 by 2, that is equal to 1. 1 is nothing but 2 by 2. So it is, in other words, you can treat 1 as 2 by 2. In other words, this is 1 by 2. This is, you can treat as 0 by 2. So finally, what you have understand, what is the meaning of 2 by 2 or what is the meaning of 1 by 2 means, you have to divide the space between these two numbers into two equal parts. And 1 by 2 represents the first part of the 2 parts and 2 by 2 represents the second part of the 2 parts. For that reason, we have break this distance into 2 equal parts. This is one part, this is another part. For the first part 1 by 2 and second part 2 by 2, which is also written as 2 by 2. Okay, then what is the 3 by 2? Again, you have to make that space between these two also two parts. Then this is the 3 by 2. Then what is this? Which is nothing but 4 by 2. What is the value of 4 by 2? That is nothing but 2. Here there is the 2. In this way, we will represent rational numbers in between the integers or in between the main numbers on the number line. Okay, what is the case of how we will represent 1 by 3? For this purpose, what you have to do means, we have to make the space as into 3 equal parts. Basically, one thing you have to remember is what is the value in denominator. So what is the value denominator? What is the value in denominator? You have to make, if you value in the denominator, you have to make that number of equal parts. Here we are having 1 by 3. The denominator is 3. So you have to make 3 equal parts. And what numerator tells? Is that is the 1th part. That is the first part of 3 equal parts. First part of 3 equal parts. Okay, denominator, what denominator tells? Denominator is that number. Denominator tells that number of equal parts. So what in the case of 1 by 3, 3 is the denominator, so you have to make 3 equal parts. Then what numerator tells that first part of 3 equal parts. If it is 2 by 3, then second part of 1 by 3, second part of 3, like that you have to represent. Here if you have see, it is the 0 and it is the 1. Here denominator it is having 3. So what you have to do, you have to break this into 3 equal parts. 1 by 3 means the numerator 1 means the first equal part, 2 by 3 means the second equal part, 3 by 3 means the third equal part, which is also anything but 1. In the same way, 4 by 3 is the fourth part, 5 by 3 is the fifth part, 6 by 3 gives rise the 2. Like that you will represent the rational numbers on number line. If there is 1 by 8, you have to make 8 equal parts, spacing lines between 0 and 1 or anything like that. 1 by 2, 2 by 3, 3 by 8, like that you will get observed. Okay, if you have 9, if you have denominator 9, you have to make 9 equal parts, and 4 by 9 represents the fourth part. In the same way, for negative side also, if you have 4, you have to make 4 equal parts, if minus 3 by 4 means it is representing minus third part of the fourth part, minus 7 by 4 means it is representing the minus seventh part of the fourth part, like that. In this way you are representing rational numbers on number line. Okay, now we have completed a third topic. Also we have entered into the fourth topic, which is nothing but rational numbers between rational numbers. Basically rational numbers are in the p by q form and they are between integers, like that, integers on number line. Then what are the rational numbers between rational numbers? Rational numbers between rational numbers. How we can find rational numbers in between rational numbers? Basically if you take 1 and 5, these are the integers. The integers between 1 and 5. What are the integers between 1 and 5? They are 2, 3, 4. Then if you take these are the natural numbers. If you take minus 3 to 2, these are integers. Then what are the integers between those, which are minus 2, minus 1, 0 and 1? Now if you take rational numbers, like what are the rational numbers we are going to take here? Suppose take 3 by 10 and 7 by 10. These are the rational numbers. Then what are the rational numbers between them? How can you find out? Then you will say after 3 by 4, it is the we have making 10 parts. We have denominator tells that you have to make space into that much of equal parts. You have making 10 equal parts, and 3 represents the third part of the 10 equal parts. Then this is the seventh part of the 10 equal parts. Then we will have 4 by 10, 5 by 10, 6 by 10. So you will say there are three numbers between rational numbers. Is it true? I am asking you one question. Is it true? There are only 3 numbers. If you say it is true, comment below. Okay, I will prove you that there are more than 3 numbers in between these three rational numbers. Then how, sir? How means just come with me, just listen. This is 3 by 10, this is 7 by 10. Okay, if I multiplied it with 10 by 10 on numerator and denominator, does its value change? No, because 10 cancel, its value is 1. 1 into anything gives rise the same. At the same time, I will also multiply this with this also with 10 by 10. What happens? Then also its value does not change. Then what is this value becomes 30 by 100. Then what this value becomes 70 by 100. Then what are the rational numbers between these? If you really concentrating on the subject, then what I have previously told you, then the denominator tells the how many equal parts we have made. So here 100. So how many equal parts you have made? You have made 100 equal parts. Then what numerator tells? Numerator tells which part you have taken out of 100 parts. Here this is 30th part of 100 parts. Then how many parts are remaining? There are so many parts remaining, that is 31 by 100, 32 by 100, like so on. There are so many numbers between 32, 70 and finally 69 by 100. Then there are so many rational numbers between these two rational numbers. What are these two rational numbers means? You may think this is the 30 by 100, 70 by 100, but they are not 30 by 100. They are 3 by 10 only. They equals to 3 by 10 and this equals to 7 by 10. So between these two numbers, there are how many rational numbers you are having? You are having so many rational numbers, but previously you told there are only 3 rational numbers. So what we can finally understood is, in between integers you are only having fixed number of integers. In between natural numbers you are having fixed number of natural numbers, but in between rational numbers we are having so many number of rational numbers. We are having so many number of rational numbers. They are not fixed. Why? Because if you say, sir, only these numbers, then what I will do? No, I will do here. I have multiplied with 10 by 10. Now I will multiply with 3 by 10 with 100 by 100. What happened? This is basically 3 by 10. Its value is 3 by 10. This is equal like then 300 by 1000. Then what? How many? Denominator divides 1000 equal parts. Then what happened? It is the 300 part only. Then it will become 700 by 1000. So how many numbers in between these two numbers? There are so many. No. If you say, sir, these are also fixed, sir, then I will add another 0. If you say, sir, those are also fixed, sir, then I will add another 0. If you say, sir, those are also fixed, sir, I will add so many zeros. So the numbers will goes on increasing. So finally what you have concluded that the rational numbers there are so many rational numbers in between rational numbers. Finally one conclusion I am going to give you. There are so many I am writing very big, so many rational numbers we can write or we can represent on rational numbers. There are so many rational numbers in between rational numbers. So you have to blindly believe it. You have to blindly remember it. It is a very important topic. There are so many rational numbers in between rational numbers. Okay, this is the one way of finding rational numbers between rational numbers. The second method of finding rational numbers means it is very simple. If there is 1 and there is 2, 1 by 1 we can write it as 1, 2 by 1 we can write it as 2. These two are the rational numbers. If you want to find the rational number between 1 by 2, what is the basic rational number? That is 1 by 2. Okay, 1 by 2, which means 0.5. So it is not 1 by 2, it is basically 3 by 2. 3 by 2 means 0.5. Sorry, 3 by 2 means 1.5. This lies between 1 and 2. Okay, 3 by 2. So we have find out this. We can find out this in the using the concept of mean. What is the concept called? Mean. We have previously learned about this mean. If you want mean of any two numbers, what you have to do? You have to add those numbers and you have to divide with the number of numbers we are having. Suppose you want to mean of A and B. What you have to do? You have to add those numbers A and B, which means A plus B, divided by the how many numbers you are having? You are having A and B, which means two numbers. So you have to divide it with 2, so that you will get the mean of those two numbers, so that you will get the middle of those two numbers. In this way, if you know two numbers or two rational numbers, by using the mean formula, you will get another rational number. Okay, suppose here 1, here 2. These two are the rational numbers. Then if you want the mean, if you find out the mean, that is 1 plus 2 divided by 2 plus, then how many numbers are there? Here 2 numbers, so you have to put 2. Then you will get 3 by 2. So this is the basic rational number we have initially assumed. Now we have assumed 3 by 2 as the rational number between 1 and 2. Finally, by using mean method, you get that rational number. So you may say, sir, in this method you can get only one rational number, sir. I am so disappointed, sir. Then I will say, don't worry, my child. I will help you to find so many number of rational numbers between 1 and 2. Then how, sir? Then how, sir? Means if you want to find a rational number between any two rational numbers, what you are doing, you are finding the mean. So basically in between 1 and 2, you have, by finding the mean, you have found this rational number. If now again what you have to do, if you have to take these two numbers and again you have to find mean for these two numbers, then you will get another rational number which is in between those numbers. So just I am going to give a clarity. The number which is in between these numbers is also the rational number which is in between these two numbers is also the rational number in between these numbers also. Can you understand it? Suppose if you are getting any rational number here which is in between 1 and 3 by 2, which is also in between 1 and 2. Okay, in that way, suppose you take 1 plus 3 by 2 divided by how many numbers you are having? 1 and 2. So 2. What is the answer? 2 plus 3, which means 5. 5 by 2, and here it is the 2. Here it goes to the denominator. So finally answer will be 5 by 4. Okay, 5 by 4. Okay, is it correct? 2 ones are 2 plus 3. How much it is? 5 by 2. So in the same way, what you are having? 2 into 2, 5 by 4. So you are getting another rational number 5 by 2, which is between 1 and 3 by 2. So 5 by 4. So it is between 1 and 3 by 2. In the same, it is also between 1 and 2. So how many rational numbers you are getting between these two rational numbers? You are getting two rational numbers. If you again do mean for these two, you will get another number. If you again do mean for these two, you will get another rational number. If you again do mean between these two, you will get another rational number. If you again do mean between these two, you will get another rational number. If you again do mean between these two numbers, you will get again rational numbers. If you get some other numbers, if you again do on goes on, if you goes on finding mean to all adjacent numbers, you will get so many rational numbers in between rational numbers. So finally, what is the conclusion statement is, there are so many rational numbers in between rational numbers. Finding rational numbers, we have two methods followed. One is the mean method, and another one is by multiplying and dividing. So these two are the two methods to find rational numbers. Finally, we have completed our chapter completed, students. We have finished 4 topics. Now what we are going to have, we are going to see the summary of the whole chapter, of the whole 4 topics. Are you interested, guys? If you like the session, if you like the concepts, please comment below. Please give a like and share these videos to your friends. Okay, now first rational numbers, it is in the introduction. We have seen solving some equations. By that we find a new number which is in the form of p by q, so we call that as rational number. Basically rational numbers are in the form of p by q, and p and q are nothing but the integers which we have previously learned numbers, and p q not equals to 0. We have previously learned how to add, subtract and make basic operations between rational numbers. So in this chapter we are going to have the properties of rational numbers. Basically we have studied the properties of rational numbers. So first property is closure property. We have studied rational numbers under closure property, and in the case of addition it is true, it is satisfied. In the case of subtraction it is true, satisfied. In the case of multiplication also it is true, satisfied, but in the case of division it is not satisfied. Closure is not satisfied. And the next property is commutative property. This property for rational numbers under addition is satisfied. This property under subtraction for is not satisfied, and for multiplication it is satisfied, and for division it is not satisfied. And again coming to associative property, this property for rational numbers under addition is satisfied. Basically a plus b plus c is equal to a plus b plus c, satisfied. For subtraction it is not satisfied, but for multiplication it is satisfied. A cross b cross c equal to a cross b cross c. Finally for division it is not satisfied. What is that property which is not satisfied here? Associative property. Then for the rule of 0, so 0 is called, what we called as 0 is called the additive identity of rational numbers. If you add any number to any rational number to the additive identity, you will get that same rational number only. Then what is the role of 1 is the multiplicative identity of the rational numbers. If you multiply any rational number with the multiplicative identity 1, you will get that rational number. Okay, then what is the negative of a number? What is the negative of a number? If you add any number to its negative number or its additive inverse, you will get 0. You will get 0. So finally, minus a by b is the additive inverse of a by b, and a by b is the additive inverse of minus a by b. Then what is the reciprocal? Reciprocal is nothing but the multiplicative inverse or reciprocal, which means if you multiply any number with its reciprocal, your answer will be 1. If you multiply any number with its multiplicative inverse, you will get 1. Next property is distributive of multiplication or addition for rational numbers. This property is satisfied by rational numbers. A cross b plus c is equal to a cross b plus a cross c. So finally, we have completed all the properties under all operations for rational numbers. Now we get into the third topic, how we are representing the rational numbers on the number line. Basically, we are representing the rational numbers on the number line in between the integers, and they are extending to the right and to the left. The denominator tells the how many equal parts you have to break between integers, and the numerator tells the which part it is. If there is 3 in the denominator, you have to make 3 equal parts, and the numerator, if there is 1 on the numerator, which tells that is the first part. In the similar way, you can represent rational numbers on the number line. Then finding rational numbers in between rational numbers. So how can you find the rational numbers in between rational numbers? If you have 3 by 10 and 7 by 10, basically 4 by 10, 5 by 10, 6 by 10 are the common rational numbers between rational numbers. If you want more, find more rational numbers, you have to multiply boundaries of the rational, which means 3 by 10 with 10 by 10, 10 and by 10, you will get 30 by 100, and 7 by 10 with 10 by 10, then you will get 70 by 100. So you will get so many rational numbers. If you want more rational numbers, you have to multiply with 100. If you want more, if you want to multiply with 1000, like that doing process, you will get so many rational numbers. In another way, finding rational numbers is finding mean between two rational numbers. So we will get a new rational number. Again, finding mean with the new rational number, you will get another rational number. In this way, you can get infinite so many number of rational numbers. So finally, what the one thing you have to put in mind is there are so many rational numbers in between rational numbers. We can find, or we can create, or we can represent so many rational numbers in between rational number, guys. So finally, what happened? Our chapter is completed, our summary is also completed. We are fully confident with the concepts. With studying these concepts, you go through the text, when you go through the problems, you will surely crack all the problems, you will surely solve easily all the problems. So do practice those so that you will get good command on the whole concepts and the whole problems. If you really want, if you are really interested us to make videos on exercise problems, so please feel free to comment below. So if you get enough number of comments, then we will surely solve all the problems on the exercises, and we will upload in our channel. So finally, we have coming to the end where we are going to end this session. So please subscribe our channel, please like and share our videos, and we have different channels for 9th and 10th and interpass for 11th and 12th CBSE. So please subscribe our channel and share our videos. Also join on Telegram, follow us on Instagram. So finally, have a nice day, keep learning, bye bye.